Today we're going to talk about using complex exponentials to integrate combinations of trig functions. For example, something like sine x times cosine of 3x. Apologies if I sound tired, it's a little past midnight. So here are the identities that you need to know and understand are cosine of x is equal to e to the ix plus e to the negative ix over 2, and sine of x is equal to e to the ix minus e to the negative ix over 2I. Notice the differences. The sine function has a negative in the middle and an I on the bottom. The cosine does not. So we're going to apply this to this trig function, rewriting sine x as e to the ix minus e to the negative ix over 2I. Cosine of 3x becomes e to the 3ix. Notice that instead of x we had 3x, so everywhere you see x you just write a 3x instead, plus e to the negative 3ix. This is over 2 dx. Now, the bottoms you can pull out in front, so 2 times 2I becomes 1 over 4I. And then what you're going to do is FOIL out the top. So e to the 3ix times e to the ix becomes e to the 4ix. And do the outside terms now. E to the ix times e to the negative 3ix becomes e to the negative 2ix. Inside terms, e to the negative e to the ix times e to the 3ix becomes negative e to the 2ix. And last terms would be negative e to the negative 4ix dx. Okay. Now that we have the terms expanded into a combination of a linear combination of terms, we can integrate them term by term, remembering our shortcut for integrating linear functions, or functions containing linear functions. So this becomes e to the 4ix. You divide by the constant, which is 4I. Same thing here, plus e to the negative 2ix divided by negative 2I. Same thing here, minus e to the 2ix divided by 2I, minus e to the negative 4ix divided by negative 4I. What we're going to do here is just rearrange the terms so they're a little easier to work with. We're going to put the terms that have similar exponents together. So we're going to write e to the 4ix over 4I. And we're going to move this term right next to it. Notice that there's a negative negative, so this becomes plus e to the 4ix, negative 4ix over 4I. And we're going to put the other two terms together as well. This is minus e to the 2ix over 2I minus e to the negative 2ix over 2I. So I listed everything. Oh, these integrals are gone. We already did the integral. Okay. I want all my positive exponents to come first when I line them up. So I put those first. And I just group together similar terms. Now, putting these over the same denominator. In this case, I want to have a positive number or positive coefficient on the leading exponential. I don't have that here, so on these two terms, I'm going to factor out a -1. And then put them over the same denominator. Okay. So once you have the coefficient on the leading exponential positive, you just need to take a look at the sign in between them. That decides whether you're going back to cosine or sine. If it's positive, you're going to go back to cosine. If it's negative, you're going to go back to sine. There's no ambiguity. There's only one correct answer. So in this case, we're going to go back to cosine for both of these. So in order to go back to cosine, we need to have just a 2 on the bottom. So this one looks like we're pretty much done. We've got a 2 on the bottom. There's an extra I, but that's okay. This one we don't have a 2 on the bottom. So one of the ways I like to do this is I'm just going to take these two terms and multiply by 2 over 2. The reason I do that now is because this 2 and these terms will become cosine. Similarly, this 2 and these terms will become cosine as well. I can multiply by 2 over 2 because 2 over 2 is just 1. It's not changing anything. So what am I left with? I have 2 over 4i, and then the yellow highlighted part becomes cosine of not x, because you don't have x up here. You have 4x in the numerators, in the exponents, so this becomes cosine of 4x. And then same thing here, what am I left with? 1 over I. And then the highlighted blue part becomes cosine of 2x. Now I started with a real valued function. There's no i's in here, so I need to end without i's. So lastly, I'll just distribute this constant on the outside. I'm going to get 2 over 16 I squared cosine of 4x minus 1 over 4i squared cosine of 2x. And again, remember that I squared is -1, so this becomes -1 over 8 cosine of 4x minus, or plus, because the I squared is -1, 1 over 4 cosine of 2x plus c.